because I hate when I forget to turn on the recording. Then I have to go back and re-record the whole thing. That's not cool. All right. This week we have two basic things that we're going to be doing. We're going to be solving absolute value equations, and we're going to be graphing absolute value equations. I think the graphing part is going to be super, super easy for you guys that understand how to shift the parent function left, right, and all that kind of stuff. Then it becomes really easy. If you don't understand last week's transformation stuff, you might struggle this week on the shifting the graphs around. So let's discuss. Imaginary unit. That does not look like. That's not what I thought this week was. Oh, that's week 5. Why is that week 5? Week 5 should not be up there. All right. Did I? Oh man, I loaded week 5 instead of week 4. I am sorry, you guys. 1 second here. I'm like, oh my goodness. I think I know what we're doing this week. I think we're doing absolute value functions. So let me take a second here. It takes a little bit for files to load. So 1 second. I've got to get week number 4 here, because you do not want to see week number 5 right now. Imaginary numbers are a little bit tougher than what we're doing this week. So let me get week 4 in here. Maybe I thought it was week 5 already. All right. Keep saying, okay, so week 4. Oh, there we are. Okay. Oh, no. Okay. I think I've got it. All right. Phew. Okay. Now, this week we're going to be doing, as I said, 2 different things. We're going to be talking about graphing absolute value functions and solving absolute value functions. The graphing part, I think, is super easy if you understood last week's transformation stuff. Okay, so for example, an absolute value function, and let me just talk about what an absolute value function graph looks like. Y is equal to the absolute value of x. This will be the parent function, okay? It looks like this. It starts at the origin, and the slope is 1. So over 1, up 1, over 1, up 1, over 1, up 1, over up 1. And then on this side, it does exactly the same thing. So an absolute value function looks like a V. Okay, that's what the graph looks like. So now, this week, we're going to be graphing absolute value functions. As long as you know what the parent function looks like, shouldn't you be able to graph all of them? So what if I asked you to graph this equation? Y is equal to the absolute value of x plus 4. What would it look like? What would that function look like? It moves up 4. It will look exactly like this one, but shifted up 4 units. So I'm just going to shift this up 4 units. The slope is still 1. Will I be looking at your slope this week when you do these graphs? Yes or no? Will Mr. Shanklin? Oh, absolutely. Because if I change the number in front, let's say I put a 2 here. What does that do to the graph? Okay. I know. Makes it steeper. It changes the slope. Makes it thinner. I agree with both of those. So I'm going to be shifted. It's going to shift up 4 units. Okay, so up 4 units. But instead of having a slope of 1, this number in front really is a slope. So my slope would be 2. So I'd go over 1, up 2, over 1, up 2, over 1, up 2. And those of you that said it's going to be thinner, I agree. For those of you that said it was going to be narrower, I agree. Because now my slope is 2. It's going to go up faster. Okay? So that's a transformation. We're going to be dealing with transformations this week, but of only one distinct type of graph, absolute value graphs. That's it. We're only going to be dealing with absolute value. So if you know what the parent function looks like, every other graph that I can give you should look rather or very easy. Okay, so let me get rid of this. I want to put one more example up there for you guys. Okay, so what would this graph look like if I asked you to graph? Let me see here. Let me change color here. What if I asked you to graph y is equal to the absolute value of x minus 2 plus 5? Okay, what is that going to look like? How is it going to be shifted? Okay, it's going to right 2 places, up 5. And the graph is still going to look like a V, isn't it? What is the slope going to be on that graph? The slope is going to be 1. That's exactly right. So if I was going to graph this thing, everybody said up 5, and then to the right 2, and then my slope is going to be 1. So I have to make sure my slope is 1, because if not, Mr. Schenklin's going to mark it wrong, because that would not be the right graph, correct? What do you think would happen if there's a negative in front of here? Upside down, right, because it's a negative 1. It's going to flip it. It's just going to go down this way, right? It's going to, the shifting is going to be the same. It's going to be shifted up 5 units. It's going to be shifted 2 to the right, but it's going to be flipped over. Good. That is going to take care of half of the assessment this week. Easy peasy. What if you don't have graph paper? Okay. Would I accept these graphs if they're not on graph paper? Yes or no? No way. No, I would not. Why not? Because if you don't have graph paper, how do I know what your slope is? How do I know how far you moved up and down? No, Desmos, out of the question, because Desmos, you don't need to know how to do it. So let's say you don't have graph paper, you can't use Desmos. What would be an easy way of doing it? Ah, the note-taking thing that you gave us at the beginning of the summative. Right, Jamboard. Jamboard has the problem in there already. It has the graph paper. All you'd have to, you could print that off, or you could just do it right on the screen. Okay, so if you're struggling with graphing, it's right there. If you did it in Jamboard, I already have the problems right there. The graph paper's right there. All you'd have to do is just take it and just graph it out. Okay, that's one way of doing it. Okay, but I know a lot of people, they already have graph paper. They can do it on paper and pencil. That's fine. I'm just giving you another way of doing it if you didn't have that. All right, the second type of problem this week is going to be able to solve an absolute value equation. Okay, so let's start off with some simple ones. Nope, I don't have a clean sheet of paper. Okay, so I guess I'll go back. Here is the easiest equation I can ask you to solve. What if I asked you to solve the absolute value of x equals 2? What would my answer be? 2 and negative 2. Oh, you guys must have watched the pre-recording, the lesson tutorial. You're absolutely right. You're going to end up with 2 answers this week when you're solving an absolute value equation. Okay? Now, what are the steps? Step number 1, you have to isolate the absolute value symbol. Number 1, isolate the absolute value. What does that mean? Isolate. Okay. If I gave you something like this, if I give you the absolute value of x plus 5 is equal to 10. Isolate the absolute value means that on one side of the equal sign, you have to get it all by itself. The insides stay, but there's nothing on the outside. For example, if I had 2, the absolute value of x plus 5 is equal to 10, the absolute value symbol is not isolated. There's a 2 outside of it. I have to get rid of that before I can rewrite the problem. So I would just divide both sides by 2, and I'd end up with the absolute value of x plus 5 is equal to 5. That's what it means to isolate. What if I had something like, let's say I had 2, the absolute value of x plus 5 minus 4 is equal to 16, okay? Now I look at it and it's like, oh my goodness, there's two things outside of the absolute value symbol. There's a 2 and there's a -4. I've got to get rid of both of them. So I have isolated it. Okay, -4. I'm gonna add 4 to both sides. Why am I going to add 4? Because this is a -4. How do you get rid of a -4? You add 4. Okay, you do the opposite. So now I'd end up with 2. The absolute value of x plus 5 is equal to 20. Now I have to divide through by 2. So the absolute value of x plus 5 is equal to 10. Now I'm not done. Okay, I'm not done yet. Once you have the absolute value, so I just talked about step 1, isolating the absolute value. Once you have the absolute value isolated, then you write it as 2 separate problems. So this problem I'm going to write as x plus 5 equals 10, or x plus 5 equals -10. You have to rewrite it as 2 separate problems, one positive, one negative, and then you solve. So I'm going to subtract 5 here, so I get x equals 5. Or I'm going to subtract 5 here, I get x equals -15. Those are my 2 solutions. Now, where was that original problem? It was right here, right? This was the original problem. You can check yourself. Plug 5 in here. If you put 5 in here, you get 5 plus 5, which is 10. The absolute value of 10 is 10. 2 times 10 is 20. 20 minus 4 is 16. It works. Then if I put -15 in here, -15 plus 5 is -10. The absolute value of -10 is +10. 2 times 10 is 20. 20 minus 4 is 16. It works again. So you can always check your answer at the very end just by plugging it back in. So let me erase everything I wrote. Okay, so let's try this problem right here. You guys can't see my marker. All right, so let's try this problem right here. Nope, I want to try this one right here. Let's get rid of this. Don't want that. All right, so what is my first step going to be there? I have 9. The absolute value of x minus 4 equals 81. What will my first step be? Divide by 9. Absolutely. I'm going to divide by 9 on both sides. So then I'm left with the absolute value of x minus 4 is equal to 9. Absolute value is isolated. So now I make 2 equations. X minus 4 is equal to 9, or x minus 4 is equal to -9. And now I just solve. I add 4 to both sides. So x equals 13. Add 4 to both sides. X equals -5. Okay, check myself. I put 13 in here. 13 minus 4 is 9. The absolute value of 9 is 9, so 9 times 9 is 81. Works. 13 is good. Try -5. So if I put -5 in here, -5 minus 4, that's -9. The absolute value of -9 is 9. 9 times 9 is 81. It works. Boom. They both work. Isn't that amazing? Love it. Now, this second problem, the reason I crossed it off is because it's a little tricky. In this problem, I'm just going to put a 1 in front of here, okay, just because. So I'm just going to put a 1 here, so I'm going to change that subtraction and make that -1. All right. It is a sneaky problem. This one is very sneaky. First thing I'm going to do is I'm going to subtract 2 from both sides. So I'm left with -1. The absolute value of 2x minus 5 is equal to 5. I'm going to divide by -1. So I'm left with the absolute value of 2x minus 5 is equal to -5. This problem cannot be solved. Why not? There's no solutions to this problem. Why can't I go on any farther? Why do I know I can't? There's a 2x. No, absolute values can't be negative answers. When you take an absolute value of anything, I mean, if you take an absolute value of -10, you get +10. You take an absolute value of 10, you get 10. How are you ever going to take an absolute value of something and end up with a negative number? Can't happen. So if you ever, isolate your absolute value and it's a negative number, there's no solutions. You can't take an absolute value of something and get a negative number. That's impossible because an absolute value is always positive. So you just got to be real careful. That is a tricky problem. I'm not sure I didn't make up the answer key yet, so I'm not 100% sure if I have one like that on the assessment or not. It is tricky. It is Mr. Shanklin being tricky at it. Okay, so now let's go to our practice for this week. So here's the Desmos presentation. I want you guys to click into that, get into the Desmos presentation. Let me see, I'm in it already. Awesome. So I'm going to, I've got to share this, share my screen so we're all seeing the same thing. Share an application, Chrome tab. All right. So what I am on, I'm in Desmos. I'm on screen number 3. It's the first problem for tonight's practice. Okay, now, is there any work to do here? Yeah, all the practice are all multiple choice. Is there any work here? No. So it says graph the absolute value equation. So they're already graphed for us. Y is equal to the absolute value of x plus 4. Which answer is correct? D? I disagree with D. B? I agree with B. Why do I agree with B? I agree with B because it's inside the absolute values. So when it's inside the absolute values symbol, it means it's going to shift it left or right. If it's on the other side of the absolute value, then it's going to move it up or down, right? Okay. So it's plus 4, so that means it's going to move it to the left 4. So I agree that the answer is 4. Okay, does that make sense? I don't want to go on if it doesn't make sense to kids. So what we learned last week really does come in play this week, right? With shifting things. If you understand how to shift things, it's super easy. Is there any sneaky problems like last? What was a sneaky problem from last week? I didn't think last week was sneaky. Oh, the practice ones? Question 4 on the summative? Question 4 on the summative. I have to think about question 4 on the summative last week. I don't even remember what question 4 was. The multiple choice one? Oh, I don't even look at the multiple choice ones. Sorry about that. I don't look at the multiple choice ones. They're like, they're multiple choice. So I don't remember what it was. I'm so sneaky, it's wrong. All right. Sorry about that if I made a sneaky one. But remember, you can always take those every assessment twice. And even if you wanted to take it a third time, then all you have to do is just email me your answers along with the work for it. So you can always redo any assessment. All right, so we agree the answer is B there. So let's go to problem number 2 for this week. Oh, another nice, easy one. No work to be done here, right? We have y is equal to the absolute value of 2x plus 3. Oh, boy, what does that mean? All right, so which one is it going to be? To the left, okay, and flipped upside down, right? So letter D, I agree with letter D. Yeah. A, oh, you're moving it to the right. Remember, you always move it opposite of what's inside. So it's a plus 3 halves in this one. So it's going to move it to the left. Yep, got to be real careful with that. So the only one that's moving to the left is letter D. So the answer should be D for that one. All right. Number 3 on the practice. Uh-oh. All right. So now number 3 getting a little bit tougher because now we have to solve using an absolute value. So I'm gonna do the first one, and then I'm gonna let you guys do some work after that. Okay? So you hear crickets? I do too. Yes, I am outside working right now. All right. And I get paid for this. I love it. All right. So my first problem, number 3 on the practice, it says negative 3x plus 2 absolute value minus 4. What? Oh, no. All right. I thought this was a problem that we had to solve. It's not. It's one of the. It's another one that we have to just find the vertex. Well, what the heck is the vertex? Okay. Do we use graphing calculators for? I would expect you not to use one, but would I be able to tell if you use one? No, I would not. So what is a vertex? A vertex is where the graph has, like, I know this is called the vertex of a absolute value function graph. Okay, so I need to know where that is. Well, we're shifting down 4 units, right? So 1, 2, 3, 4. So we shifted down 4 units, but then how far do we shift left or right? Well, it's whatever makes this equal to 0. So it's going to be negative 2 over negative 3, so 2/3. That negative in there is going to cause some problems for some kids for those. So that one, now somebody go to Desmos, please. Okay. Because I'm gonna go to Desmos. I apologize. I don't need anybody to go there. I'm gonna go to Desmos because I'm not 100% sure I'm correct on this problem. So as a student, the first thing I would do, and I will get you guys to see what I'm seeing in just one bit. I gotta write it down because I'm old and I will forget once I go to Desmos. All right. So what I'm doing right now is I'm going to share my screen again. I'm going to share Desmos calculator. Okay. So let me get that. Okay. So there's my calculator. Okay. So hopefully you guys should be able to see the Desmos calculator. I wasn't 100% sure on the graph of that. I knew it was going to shift down 4 units. I knew that. Okay. But is it going to shift to the left or to the right? I really have negative 3/2 in there. Okay. So to be on the safe side, I'm going to go and I'm going to graph this out. I've got negative 3x plus 2, absolute value symbol, and then minus 4. Okay, so it looks like it shifted it to the right, and that's exactly what I was thinking, because we have that negative inside. So it was really negative 2/3, which really would shift it to the right 2/3. So my vertex would be 2/3 negative 4 for an answer. So the answer to this problem, let me turn off the thing here. I'm sorry. Sometimes it takes a while for the computer to catch up to where we're going. Okay, so let me see here. Google Chrome, Algebra 2. Okay, so that should be right. So right now you should be seeing the screen again, hopefully. So when I was doing this, I'm looking at this and I'm seeing, okay, I've got negative 2 over it's 2. Sorry, it's 2 over negative 3. So that's how it's going to shift. So it's negative 2/3. So it should be shifting to the right 2/3. So my vertex should be 2/3 comma negative 4 on this one. 2/3 comma negative 4. So it should be that one. Okay. Does that make sense? That was a little bit tricky. Okay. So let's go through another. Now you won't. I didn't put any negatives in the absolute values when we're graphing them. Where did the 2/3 come from? Okay, good question. What if I asked you to solve this equation? What if I, hopefully you guys factored already, when we have a problem like x plus 5 is equal to 0, whatever makes inside the parentheses equal to 0 is a solution. That would be -5, right? Okay. Same thing here. What we're trying to do is we're trying to make, so if I asked you to graph x minus 4 plus 5, and I said, what is the vertex? Well, it's really, we're going to shift up 5 units, but we're going to shift over 4 units to the right, correct? Because what makes this equal to 0? 4 does, and what I'm moving up or down 5. So that is, when we're talking about our vertex, it's whatever makes this equal to 0. Well, if I had -3x plus 2, what makes that equal to 0? I'd subtract -2 off there, divide through by -3, it would be 2/3. So that's where the 2/3 came from. Parentheses and absolute value symbols, they are the same thing. They are the same thing. You always have to do inside them first. Okay. All right. And I don't think there's anything like that on the assessment. I really do not. That was a tough one. That was a little mind-boggling there. All right. Let's go to problem number 4 on this the practice this week. It says write the, we have to write an equation. It says write the equation for the translation of y is equal to the absolute value of x. So what they're asking you to do is they're asking you to write an equation for this function. Okay? That should be pretty easy, right? Letter B. It's just shifting up 4 units, so my answer should be y is equal to absolute value of x plus 4. What was the answer for number 3? I think if I go backwards, I lose everything I wrote. So I'm not a... Yeah, I don't think I can... Well, maybe I can. Oh, yeah, there you go. So 2/3 and -4. So letter B should be the correct answer, because it asks what is the vertex. All right. So number 4, pretty easy. Number 5, it says graph the equation of y is equal to absolute value of x translated 4 units up. Oh no, Mr. Shanklin, you're making these way too easy on us. Letter A. All right. Shifting 4 units up just gives us letter A. I agree with that. Good. Well, no, because now we're going to get into solving. Now, these are much harder. Okay? Now, if you guys were paying attention just a while ago, what's my answer to this problem? It's this one again. Yeah, there's no solution. Because remember, if you subtract off 2, you end up, and then divide through by negative, you end up with a -5. You can't have an absolute value equaling a negative number, so there's no solutions there. All right. Now, problem number 7, I'm gonna turn off my mic. I'm gonna let you guys work on it. Okay. Here is number 7. We have -6 plus the absolute value of x minus 4 is equal to -6. This is going to be your guys' first one that I want you to really take your time and work it out. Okay, this is slide number 9, and I'm going to turn off the mic. I'm going to let you guys work and see how you do. I'm not going to say 0 is my answer. Okay, all right. I was going to say 0. I'm not so sure 0's the answer there. All right. I would disagree with no solution also. High is definitely not the correct answer. It's nice, but it's not the correct answer. All right. Let's take a look at this problem. I'm gonna work it out step by step. Okay. I have -6 plus the absolute value of x minus 4 is equal to -6. Is the absolute value symbol isolated already? Okay. Nope, it is not. So what do I have to get rid of? -6. I have to get rid of the -6, right? So I'm going to add 6 to both sides. That's the only way to get rid of a -6 is to add 6 to both sides. So that's what I'm going to do. I'm going to add 6 to both sides. Now, just because it becomes 0 over here doesn't mean there's no solution. I still have the absolute value of x minus 4 is equal to 0. That 0 is a number. Well, I can deal with that. Okay, we get 0. But now I have it isolated. So I'm going to rewrite it as 2 separate problems. I'm going to rewrite it as x minus 4 equals 0, and then I have to solve that, or x minus 4 is equal to -0. Now, -0 is still 0, isn't it? I mean, when you think about it, it makes no difference. So I'm going to add 4 here. X equals 4. Or I'm going to add 4 here. X equals 4. So I get the exact same answer, when I solve it both ways. So I'm going to say the answer is letter A for that one. Okay? So remember, we have to isolate the absolute value, and then we have to rewrite it. Now, 99% of the time, you will not get the same number for your answer. Okay? X equals 4, X equals 4. Doesn't usually happen. But I will tell you that some kids will give me the exact same answer. They'll give me the opposite every time. They'll go, oh, x equals 4, x equals -4. X equals 5, x equals -5. They always just give me the opposite of one of the answers they find. It's like, no, that's not correct. It's not just plus or minus that answer. Okay, so be careful. I see that every year. Kids give me the exact, they'll solve it one way, and then they'll just say, oh, it's plus or minus that. No, it's not. It's not. All right, let's try number 8. Okay, we have 7. The absolute value of x minus 6 equals 49. So let me ask a couple questions before I let you guys go and work. Is the absolute value isolated? No. So I have to get rid of the 7, correct? So what is my first step going to be? Divide. I'm going to divide both sides by 7. That is absolutely correct. So I'm going to leave you guys to finish solving that. So I'm going to turn off my mic and let you guys work. Negative 7 minus 6 is definitely negative 13. No, it's 13? No, I don't think so. Not a negative. All right, let's work this one through. So we already talked about it. We're going to divide by 7 on both sides. So that leaves me with x minus 6. The absolute value of x minus 6 is equal to 7. I have the absolute value isolated. So my next step is to rewrite it as two separate problems. X minus 6 equals 7, or x minus 6 equals negative 7. I'm going to add 6 to both sides here. X equals 13. Or I'm going to add 6 here. X equals negative 1. So I'm going to go with 13 and negative 1 for my two solutions. Does that make sense? Okay. So really, this week, I think, is one of the most concrete weeks that we've had so far. And what do I mean by concrete? It's like, okay, this is what you do, and either you know how to do it or you don't. Like week number 2, we had domain and range and increasing, decreasing. What else did we have on there? There's end behavior stuff that there's a lot of stuff in there. It was just 2 things. Do you know how to graph an absolute value function? Can you solve an absolute value equation? That's it. All right, let's try number 9 on the practice for this week. Number 9, we have the absolute value of 6x minus 9 plus 5 is equal to 2. I'm going to, well, can somebody tell me what the answer is right off the bat? D, no solution. Why? Why is it so easy? Yeah, because as soon as you subtract off 5, you end up with negative 3. So the absolute value is equal to negative 3. Then absolute value cannot equal a negative number. So it would have no solutions. Okay, I agree 100%. Very nice. Very, very nice. All right. So we only have one more practice problem this week, I think. Oh, no. We did this one already, didn't we? I think we did it on when we were just going through our thing. But I'm going to turn off my mic. I'm going to let you guys work. This one should be really easy because I think we did a problem just like I think we did this problem, to tell you the truth. So give it a shot, see what you get. All right. I am sitting. I know I did not fall asleep. I'm doing the problem on the board. All right. I just forgot to turn my mic on, which happens a lot of times. When you get as old as I am, yeah, we'll just leave it at that. All right. So the first type of problems on this week's assessment are absolute value problems that the absolute value is already isolated. So what are you going to do? You're going to rewrite it as two separate problems, and you're going to solve, right? So you'll have two distinct answers for those problems. Okay, that's how problem number one is. Guess what problem number two is going to be this week? Just take a wild guess. So problem number one, absolute value functions where the absolute value is already isolated. Graphing. You are absolutely correct. You guys, you could be the teacher of this class. There it is. Graphing. Not multiple choice. No. Assessment 4B. Remember, 4A, all of the A assessments will be workout, and the 4B or the B assessments are always multiple choice. Okay, so I don't ever go through the multiple choice problems because it's like, they're very similar to the practice problems. So in this problem, how is it going to look? What is the graph going to look like? Okay, I've got y is equal to 3 times x minus 3. Okay, what should that look like? Narrow, because the slope is going to be what? Slope is 3. Y-intercept is negative 3. Y-intercept is negative 3. I disagree with that. Nah. Okay. I'm going to shift 3 places to the right. Okay, so I better get on the right screen here. So I'm going to shift 3 places, 1, 2, 3. So it's going to be there, but then my slope is going to be 3 up 1 over, or I'm sorry, over 1 up 3, over 1 up 3. So it's definitely going to be narrower. So this is what my graph is going to look like. All right, that is it for this week. As I said, I think it's a fairly easy week. It's just, can you solve an absolute value function? Can you graph an absolute value function? That's it. Finishing early. You betcha. Now, does anybody, we are early, so does anybody have any questions that they want to ask? The Unit 1 assessment, are we done with the unit already? Let me, I don't usually go in and check them out. That would just be like a unit test. So if we have a unit, yep. That's just I think it's multiple choice. I'm almost positive it's multiple choice. And it just covers everything that we've had so far. Yeah, it covers everything that we've had on there, and a lot of it is just graphing stuff. Yep. All right, you guys have a great week. Bye.